What if the most powerful computer ever imagined does not think in terms of ones and zeros, but in possibilities? What if the future of computation is not about the speed, but it's about awareness of choice? Hello guys, I am Arfat Firdos, and today I will explore quantum computers again. I find them fascinating, not just as machines, but as the mirrors of how reality itself functions. Now, because when computation becomes quantum mechanical, physics, consciousness, and spirituality quietly begin to overlap. They superimpose on each other. From classical certainty to quantum mechanical possibilities. Again, to remind you that a classical computer, to be honest with you, is rigid. It works on a bit, either in a state 1 or in a state 0. So, yes, no, right, wrong, on, off, and there's nothing between these two states. Your phones, your laptops, even the most powerful supercomputers that we have today, they all live inside this strict certainty, 0 and 1. Right, wrong, on, off. But nature does not behave like this. And if we look at the deepest level, if we observe at the deepest level, reality hesitates. And it hesitates, it explores. You know, quantum computers are built to respect that hesitation. And the birth that we have, the birth of a quantum bit in a computer, in a quantum computer, we do not use bits, we use qubits, we use quantum bits. A quantum bit is just a 0 or 1. This is not the whole reality of the quantum bit. This is not the confusion. This is superposition. It lives in both the states, zeros and ones, coexisting. And there can be infinite number of states between them. You know, not metaphorically, not mathematically, and suddenly computation stops being linear. It becomes exponential. And you think about the human mind. What we do before a decision, you are not convinced. You're not rejected. You're open. You have a range of possibilities in your mind, and a range of possibilities exist. That openness is not the weakness, basically. It's a creative power. And if we think in terms of qubit, a quantum bit behaves exactly like that. And it behaves exactly like that before any act of measurement is put on it. It doesn't commit. Why quantum computers are exponentially powerful? To give you a rigorous idea about it, one qubit can represent two states, the spin up, spin down. Two qubits can represent four. Three qubits can represent eight. Now, if I boil down it to, in general, to have that standard number of 300 qubit quantum computer, it certainly represents more states than if you can count the number of atoms that are available in the visible universe. So there's a boom of states, the bomb of states. You cannot count them. This is not faster computation. We're not talking about the fastness. This is a parallel reality processing at same point of time. And when separation is an illusion, if there's an entanglement, and now comes this strangest ingredient, what we call entanglement. If you have two quantum bits, and these two quantum bits can become so deeply correlated with each other that measuring one instantaneously defines the other quantum bit, and distance becomes irrelevant. In physics, this is something that's experimentally verified, something that's experimentally confirmed. And to counter it in philosophy, in a philosophical version, this is a revolution. And at the same time, in spirituality, this is basically an ancient wisdom that always existed. That separation is not fundamental. That separation cannot be argued as a fundamental. And this entanglement can certainly be correlated with the consciousness. Your thoughts are unified. They are unified of your vision, your memory, your emotions, and your identity. And all of these things arrive together, no one by one. This unity resembles entanglement, the idea of entanglement in quantum physics. It's not metaphorical, and it has a structure. And structurally, you have this conscious experience, a unified conscious experience. And it's not something assembled. It's something that's co-emergent. There's entanglement between all of these actions that are going on. A classical logic gate, 0, 1, we have those gates in electronics. These are all irreversible gates, like AND gate, OR gate, NOT gate. And in contradiction to this, in quantum gates, they are reversible. They rotate states in abstract space. And we have this commonly used quantum mechanical gate, what we call as Hadamard gate. This gate creates balance. It takes certainty and turns it into openness. This is not just physics. This is a principle. This is a principle that's making a transformation. You're making a transformation without destroying anything. And the act of measurement, the moment of choice. Here's a critical moment, because this critical moment is very strange, as repeatedly I'm trying to talk about. A quantum computer does not give answers until you make an act of measurement on them. And your measurement, what it does, it collapses the possibility into the fact. Before you observe it, before the observations, there are many realities, there are many truths, there are many ideas, but after observation, only one reality, just one reality. And this is something that raises a profound question. Is the observer the part of the computation? And physics quietly answers this question. And the answer comes in terms of yes. Now, to boil down this talk to consciousness as a final interface, a quantum computer does not decide, basically. It explores. It presents. It presents the possibilities. And the meaning enters only when a conscious observer reads the result of all these possibilities. So in this sense, consciousness completes the algorithm. It completes the algorithm without awareness. There's no outcome. There's no output if you have error in your work, if there is noise, and if there is any kind of frugality. It's a very humbling lesson. Quantum systems are fragile. What's happening is, if you have noise will destroy that coherence that you're interested in. This is why quantum computers, they require a complete isolation. They require some of the fundamental things like cooling. You want cooling, you want precision, and you want to boil down this frugality. You have to boil down this frugality, and what it teaches us? It teaches us something important. What it teaches us is the truth at the deepest level is delicious. It cannot survive violence. It requires the stillness. It requires a spiritual reflection, maybe through physics. And at the same point of time, we have many spiritual traditions going on this planet. And silence is something that reveals the truth. And quantum physics says decoherence destroys information. And to quote down the same thing in a different language, we have the same insight. Quantum algorithms, they have an insight. Quantum algorithms do not search step by step, they shape probability. So the right answer, the right, maybe the only probable answer becomes inevitable. This is not brute force. This is guided emergence. Perhaps I can say the intelligence. And to make a further argument on biological or artificial intelligence, they works the same way. The universe is perhaps acting as a whole quantum computer. And some of the physicists argue, what if the universe itself is computing? And particles existing in this universe, they are acting as qubits. And there are interacting gates between these particles. And time is merely an iteration. It's merely a presence in that system. And consciousness, the moment the universe becomes aware of its own states. And why this matters for humanity, it certainly has a touch on humanity. You know, quantum computers will certainly change the understanding of our nature of reality, because it will be something that we will be working on. It will be something that we will be manufacturing on. We will be looking for the rights and wrongs, the workings, the conditions, the forces that should be adopted to make this quantum computer work. And to give you the final thought, to close this argument, what I should say is, right now your brain is processing this speech, and it's not processing it deterministically. It is processing it probabilistically. Thoughts rising and meanings forming, awareness selecting what you can absorb, what you can reject. You are already a quantum participant. So I am Arfad Firdaus, and perhaps the future of computation that we can think of is not artificial intelligence that's taking our creativity out of us. It will be the artificial humility, because the deeper we go into the physics, the deeper we go into the science, the more reality whispers. I'm not what you think.